Poliovirus is the causative agent of acute poliomyelitis, commonly known as polio. The defining characteristic of this virus is the ability to cause rapid onset flaccid paralysis. Paralysis typically affects the limbs without causing any cognitive impairment. The virus is highly contagious, with nearly 100%. In severe cases, polio can paralyze the diaphragm, making independent breathing impossible. Survivors of diaphragmatic paralysis require mechanical assistance, like the iron lung, to breathe. The paralysis can begin within hours of infection and is usually permanent. Children under 5 are the primary victims of this disease. Decades later, survivors may develop post-polio syndrome, experiencing paralysis even if they were asymptomatic. Evidence of polio extends back to ancient times. This Egyptian carving depicts a priest with a withered leg, suggesting polio's ancient presence. Roman Emperor Claudius is believed to have suffered from polio as a child, resulting in lifelong partial paralysis. The first documented case in modern times was Sir Walter Scott in 1773. In 1789, English physician Michael Underwood provided the first clinical description, calling it a debility of lower extremities. Jacob Hind's 1840 report termed it the paralysis of lower extremities. By 1890, Carl Medin had begun systematic studies and classifications of the disease. The breakthrough in understanding came in 1908, when Karl Landsteiner and Erwin Popper hypothesized that polio was caused by a virus. The early 1900s saw epidemics begin to emerge globally. Polio was known by various names at the time, including infantile paralysis, creeping paralysis, and paralysis of the morning. The first polio epidemic in the United States occurred in 1843. It wasn't very notable. Then in 1916, a severe polio epidemic struck New York, with 27,000 infections and 6,000 deaths. As polio spread, summer epidemics began to become more frequent. Because children were predominantly affected, many viewed these outbreaks as divine punishment. Public health measures included quarantine notices and restrictions on gatherings. The peak of the polio crisis occurred between 1952 and 1953. With 93,000 reported cases, polio hysteria gripped the United States. Newspapers tracked daily case counts and deaths. Parents lived in constant fear during summer months, when epidemics typically occurred. Before vaccines, polio crippled 35,000 Americans annually. Hospital wards like this one in Los Angeles were filled with iron lungs. It's really hard to overstate how terrifying polio was to parents prior to the vaccine. During the 1950s, several vaccines were being developed. In 1955, Jonas Salk developed the first publicly available vaccine. A massive immunization campaign began, supported by celebrities like Elvis Presley, shown here receiving his vaccination. The impact was immediate. Families lined up around buildings for blocks, waiting to receive the vaccine. Within 1 year, polio cases dropped from 58,000 to just 5,600. Poliovirus belongs to the coronavirus family. These are small, non-enveloped viruses with positive single-strand RNA. The virus has an icosahedral capsid measuring 27 to 30 nanometers. It's related to rhinoviruses and other enteroviruses that cause hepatitis and meningitis. 3 log variants of poliovirus exist, and polio and vaccine-derived mutations. Types 2 and 3 have been successfully eradicated globally. Type 1 exists only in Pakistan and Afghanistan. Surviving infection provides lifelong immunity, but only against that specific strain. There are also vaccine-derived polioviruses. These arise when oral polio vaccines mutate in areas with incomplete vaccination coverages. Poliovirus is an enterovirus. It infects the intestines and is spread through stool via fecal-oral route. Areas with poor sanitation are especially vulnerable to polio. The virus can spread in the environment, making contaminated water sources particularly dangerous. The virus is highly contagious, with nearly 100% infection rate per household upon exposure. After ingestion, it first colonizes the gastrointestinal tract. From there, it can spread to the central nervous system and causes the neurological symptoms associated with polio. The majority of infected patients will have absolutely no symptoms and will never know they were infected. A smaller percentage will experience minor flu-like symptoms that resolve within about a week. However, in a small percentage of cases, the virus causes paralysis. This usually affects the legs and is most often permanent. Paralysis can develop within hours of infection. Of those who become paralyzed, 5 to 10% die when breathing muscles become immobile. After initial infection in the throat, poliovirus replicates in the oropharynx. It spreads through mucus and sputum for up to 2 weeks. The virus then colonizes the intestinal tract. From there, it spreads through fecal matter, remaining infectious for weeks. Within the intestine, the virus can migrate through cell walls and into the lymph system. Once inside the lymph system, it can travel throughout the entire central nervous system. It hijacks macrophages and uses the immune system for replication and distribution. This ability to co-opt immune cells is what makes poliovirus so effective at spreading and evading detection. When poliovirus reaches the central nervous system, it targets specific areas. It particularly affects the anterior horn cells of the spinal cord. Motor neurons controlling limbs, trunk, diaphragm, and swallowing muscles are primarily affected. The incubation period typically ranges from 7 to 10 days, but can extend for up to 35 days. Post-polio can emerge 15 to 40 years later and affect up to 40% of survivors. This is the distribution of clinical presentations for polio. The vast majority of cases don't cause paralysis. 3/4 of infections are asymptomatic, but they can still spread polio for up to 6 weeks after infection. Even asymptomatic cases can remain vulnerable to post-polio syndrome later on in life. About 1/4 of infections will cause flu-like symptoms. It includes sore throat, nausea, fever, headache, tiredness, and upset stomach. It usually lasts 2 to 5 days. Non-paralytic meningitis affects 1 to 5% of infected individuals. Polio attacks the nervous system, and the corresponding inflammation triggers meningitis symptoms. These are normal, standard meningitis symptoms, but they are distinctly different than paralytic polio. Paralytic polio affects only 0.1 to 0.5% of cases. It's characterized by a rapid, acute, flaccid paralysis with no cognitive defects. It has an asymmetric distribution and progresses proximal to distal muscles. Key clinical features include decreased or absent tendon reflexes. Maximum paralysis develops within 2 to 4 days of onset. The preservation of sensation and cognition distinguishes polio from other neurological conditions. Diaphragmatic paralysis causes death in 5 to 10% of paralytic cases. Post-polio syndrome affects 25 to 40% of polio survivors. The onset occurs 15 to 40 years after the initial infection. Patients experience new muscle weakness and difficulty in swallowing or breathing. It generally continues to progress and is irreversible. The poliovirus is detected using viral isolation from stool samples or throat swabs. Real-time PCR differentiates wild strains from vaccine-like strains. This shows the PCR testing process. It differentiates between the wild virus type and the target Sabin viruses, which are the oral polio vaccine-derived ones. This is the sequence showing the genome sequencing for the various polio vaccines or poliovirus. There is no treatment for poliomyelitis once you're infected. There's no antitoxin and there's no antiviral. The only defense is vaccination. There are two types of main vaccines that exist, the inactivated and the oral, the IPV and OPV. IPV requires intramuscular injection with 3 doses. OPV is given orally. Most countries have now phased out OPV in favor of IPV. Jonas Salk developed IPV in 1955. It was the first vaccine made from a dead virus. Up until that point, scientists believed that a virus had to be alive to be used as a vaccine. It was the largest vaccine trial in history and involved 1.8 million children. It provides up to 90% protection against the paralytic disease. However, it's less effective at preventing viral shedding in the intestines than OPV. At the same time that Jonas Salk was developing IPV, Albert Sabin was testing OPV. OPV was released to the public in 1961. It quickly replaced IPV due to the ease of administration. It didn't require trained personnel, and a single drop of vaccine was placed on a sugar cube and was given to a child. This made mass vaccinations a lot easier to organize. OPV also provided superior intestinal immunity against viral shedding. However, OPV has its limitations and is being replaced by IPV. OPV involves handling and storing live poliovirus and requires extensive biosafety laboratories for production. It also has to be kept in a freezer. There are other concerns with LPV as well. In cases where the immunization series wasn't completed, the live virus can mutate and become virulent again. This is called circulating vaccine-derived poliovirus. In some cases, it can also cause vaccine-associated paralytic polio, or VAP. IPV is much safer because the virus is completely inactivated. There's no risk of VAP or vaccine-derived outbreaks. Production doesn't require high-level safety biofacilities and reduces the cost. The immune response is stronger and longer lasting, and the storage is much simpler than OPV. Future vaccines are being made out of virus-like particles. We're in the process of developing new, cheaper, safer polio vaccine using VLP that contain particles that mimic the virus exterior without containing any RNA. This makes them much safer. Even though there is no treatment for polio, there is an experimental prophylaxis being developed called Poliovirus, which is an experimental capsid inhibitor that will hopefully help protect patients who are immunocompromised and are unable to take the vaccine. Polio vaccine is also being engineered to fight cancer. It is being reverse engineered as a polio rhinovirus chimera that targets cancer cells. This alerts the T cells in the body to trigger an immune response and attack the cancer cells.